Okay, y'all, good morning. Today we are going to look at finding the attributes of functional functions, and to do so, particularly the domain and range, we need to find all areas where the function is undefined or where the denominator is equal to 0 and any potential resulting outputs. So our first step is going to be to simplify this completely by factoring the top and bottom. So on the top here I have x squared plus 5x plus 6. I know I can factor this using my x factor. And on the bottom, I have x squared minus 9. I can factor this using my special case. So we'll start with the numerator with the x factor. You have your c value in the top, b value in the bottom, two numbers that multiply to 6 and add to 5 are going to be 2 and 3. So our factors are x plus 2, x plus 3. And for my denominator, my special case, that's x minus 9. When I set up my x factor, it's negative 9 in the top, 0 in the bottom. Two numbers that multiply to negative 9 and add to 0 are negative 3 and positive 3. So my factors are x plus 3, x minus 3. So I'm going to put those back into a fraction and see what cancels. If I have x plus 2 in the top, x plus 3 in the top as my two factors, and x plus 3, x minus 3 in the bottom, I can see that they're x plus 3 and x plus 3, there's one in the top and one in the bottom. If you have a factor that's repeated in the top and the bottom, it can cancel out, which would leave us with a function, a simplified function of x plus 2 over x minus 3 equals y. So this is my simplified function. I'm going to use that to help me find the attributes of the graph. Okay? We have three main attributes of our graph. The first one is our vertical asymptote. Our vertical asymptote is when the denominator is equal to 0. When my denominator is equal to 0. So if I'm finding where my denominator is equal to 0, I'm going to take my denominator of x minus 3. So I'm going to take x minus 3 and set it equal to 0. Okay. Add 3 on both sides. My vertical asymptote is x is equal to 3. That's an undefined value because we can't divide by 0. Okay, so that's the first attribute of my graph that's going to help me find my domain and range. The second attribute of my graph that's going to help me find my domain and range is my horizontal asymptote, and this one's a little confusing because there's a couple rules that go with it that have to do with the highest exponent in the top and bottom of the fraction. Okay, so you can look at your simplified function or your original function for this one. I usually look at the original, and you're looking at the degree or highest exponent in the top and bottom of the fraction. Okay, and I'm going to have these rules listed on the next slide. But if we're looking at the degree, my highest exponent in the top of the fraction is 2. My highest exponent in the bottom of the fraction is 2. So when the degree of the top is equal to the degree of the bottom, you look at your leading coefficient, which means the number in front of the highest exponent. So we're looking at the number in front of x squared, which is 1. The number in front of this x squared, which is 1. 1 divided by 1 is 1. So my horizontal asymptote is y is equal to 1. So that is another value in which our function is undefined. So the last one that we are going to look at is when we have what's called a hole in the graph. Now the hole comes from a common factor, or something that we canceled out in the top and the bottom. So you only have a hole in the graph if you have a common factor that cancels out in the top and the bottom. So here, since I had x plus 3 cancel out in the top and the bottom, this is my common factor. So I take my common factor and I set it equal to 0. So I take x plus 3, set it equal to 0, subtract 3 on both sides. The x value of my hole in the graph is -3. Okay? But the hole in the graph has an x value and a y value. So I found the x value of the hole in the graph. Now I just need to find my y value. To find the y value, you are going to take your simplified function and plug in the value you found for x. So my simplified function is x plus 2 over x minus 3. So I take my x value of -3 and I plug it in anywhere I see x. So that is going to give me -3 plus 2 over -3 minus 3. And the result will be -3 plus 2 is -1. -3 minus 3 is -6. So the y value of my hole in the graph is 1 over 6, because a negative divided by a negative results in a positive. Okay, now I know this is a lot of information, okay, but now that we've gathered this information, we can actually write our domain and range, which is the whole goal. The question says determine restrictions of domain and range. Okay, now the restrictions on the domain and range come from all these potential undefined values. Okay, so what we're going to do to write domain, I'll draw a little box here to give us some room. To write domain, remember domain is our x values. Domain is x values, so we're only going to be looking at x values. X values are our vertical asymptote and the x value of the hole in our graph. So my domain is going to be all x values, except x cannot be equal to 3, my vertical asymptote, and x cannot be equal to this -3, the x value of the hole in my graph. Now we're going to do the same thing with range, except range is our y values. So we're going to be looking at our horizontal asymptote, it's y values, and the y value of the hole in the graph. So our range is y cannot be equal to 1, which comes from our horizontal asymptote, and y cannot be equal to 1 over 6, which comes from the y value of the hole in my graph. Okay, so quite a lot of work to just write domain and range. Our main goal here is to factor, find a simplified function, and then use this function to find our vertical asymptote, our horizontal asymptote, and any potential holes in the graph. We then use these values to write the values that are not included in our domain and range. For domain, it's x values, which comes from the vertical asymptote, the VA, and the x value of the hole in the graph. And for the range, your two excluded values are your horizontal asymptote and the y value of the hole in the graph.